The product property of logarithms says the logarithm with base b of u times v is equal to the logarithm of base b of u plus the logarithm with base b of v. So the multiplication here turns to an addition. We can use that in both directions. We can both expand or condense our expression with logarithms. If we want to expand it, we can say the logarithm with base 3 of 9 times x. There's a multiplication in there, right? Logarithm with base 3 of 9 times x would then be the same as the logarithm with base 3 of 9 plus the logarithm with base 3 of x. Now this one we don't know what it's going to be here in the back, but the one in the front, we know that the number that turns 3 to 9 is 2 as an exponent. So we can simplify and we get 2 plus the logarithm of base 3 of x. If we want to condense, we can do that the same way. We have two logarithms with the same base of 2 and they're being added. So that's going to be the logarithm with base 2 of x times 7, or more nicely put, the logarithm with base 2 of 7x. So the quotient property of logarithms says the logarithm with base b of u divided by v is equal to the logarithm with base b of u minus the logarithm with base b of v. If we want to expand this, then we can write the log, and here when we have log without a base showing, that really means that we have the log to the base of 10. Remember, that doesn't need to be shown. And the log to the base of 10 of 2 divided by 7 is the same as the log, and I'm going to drop it again, as you know now what the log stands for, minus log 7. Log 2 minus log 7. And if I want to condense it, and here we have ln. ln is our natural logarithm. The natural logarithm of x minus the natural logarithm of 3 is ln of x divided by 3. Now, one word of caution here, make sure that you do not write another ln in the denominator. That is absolutely not correct and would change your answer. So it's just one logarithm of a fraction. And note that for our product property, the multiplication turns into addition, and for the quotient property, the division turns into subtraction. The power property of logarithms says the log with base b of u to the power of n is equal to n times the log with base b of u. When we want to expand this, we take our 5 and that moves to the front. So we get 5 logs with base 3 of x. And of course we can also condense this. And then the 3 will go into the exponent and we will have the log with base 2 of 3 cubed. And of course we know that this is the log with base 2 of 27. So the number that was in your exponent moves into the coefficient and is multiplied now. These three properties, the product property, the quotient property, and the power property of logarithms, are very close and very similar to those same properties that we used for exponents. Remember, multiplication is related to addition, division is related to subtraction, and raising to another power is related to multiplication. Remember those in order to keep your properties apart. And we can, of course, also put them together in an expression, and now we have an expression that we want to expand. So the first thing I want to do here is get rid of my division and write instead the logarithm with base 4 of 64 times x minus the logarithm with base 4 of y to the 5th power. And now I can get rid of my multiplication and make these the logarithm base 4 of 64 plus the logarithm with base 4 of x. And I can next move my 5 from the exponent into a coefficient minus 5 times the log with base 4 of y. Our first part we can simplify even further. What number do we need to raise 4 to 64? And the answer is 3. So we got 3 plus the log with base 4 of x minus 5 logs of base 4 of y. And in our next example, we're going to go the opposite way. We're going to condense these. First, I'll move my coefficients into the exponent again. Alright, very nice. And now I have 3 logs with base 5, and I can combine them further. These first two are subtracted. That means we have to put them together as a fraction. They get divided. So log with base 5 of x cubed divided by y squared plus log base 5 of z to the 6th power. These are being added, so then I will multiply my z to the 6th power to the x cubed for our final condensed form, x cubed times z to the 6th power over y squared. And here is our answer. As we have seen at the very beginning of this lesson, it's not always possible for us to find a log without using the calculator. I don't know what number we need as an exponent to get 3 to turn into 5. So the change of base property is a very good way of doing that, because what we do with our change of base property, we can split this expression up into a fraction of 2 logarithms with a base that we know. In this case, it would be to the base of 10, and that we can then calculate on the calculator. Just have to remember that our base will go into the denominator and our a will go into the numerator, and we can then punch that into the calculator to find the values. So the log with base 3 of 5 is the same as the log, the common one to the base of 10 of 5 divided by the log of 3. And for that we're going to use our calculator, and on the calculator you will see in the left column here, down here, we have 2 buttons, one for log, that is our common log with base of 10, and right underneath it ln, which is the natural log with base e. So the log of 5 close parentheses divided by the log of 3, don't forget to close your parentheses, enter, and that number is a decimal that we can write down. Rounding it to the thousandth, we get approximately 1.465. So that means that 3 to the 1.465th power is approximately 5. So let's see if that's true. 3 to the 1.465th power is 5 and some decimals. Okay, that's good enough for us. Let's try out our next one. The log with base 6 of 11 is equal to the log of 11 divided by the log of 6. Calculator, help us out. Log of 11 divided by log of 6 is equal to 1.338, or I should say approximately 1.338. And last but not least, the log with base 12 of 24 is equal to the log of 24 divided by the log of 12. Log of 24 divided by log of 12 is equal to 1.279 approximately. And let's just do a final check. So we are saying that 12 to the 1.279 power should be around 24. 12 to the 1.279 is equal to 24.00. All right. Okay, so much for this, and I will see you in class.